Hello friends, welcome back to my YouTube channel. Today, we're exploring corona discharge, a phenomenon that affects power transmission systems. This silent and invisible phenomenon can drain energy, disrupt operations, and threaten grid reliability. If you're visiting my YouTube channel for the first time, please support the channel by liking and subscribing to the channel. Hit the subscription button so that you will be notified for my next videos. In this video, we'll explore the science behind corona discharge, its impact on transmission lines. Let's dive in and understand what factors affect corona discharge and how its impacts on transmission lines can be mitigated. Stay tuned. Welcome back. Please, if you're not familiar with corona discharge, I recommend watching my previous video on corona effect, which is linked in the description box below. It will provide essential background information and help you better understand today's discussion. Let's get started and uncover the mysteries of corona discharge in transmission lines. Let us look at some factors affecting corona effect. The phenomenon of corona is affected by the physical state of the atmosphere, as well as by the conditions of the line. The following are the factors upon which corona depends. 1. Atmosphere. High humidity can increase the likelihood of corona discharge by reducing the air's dielectric strength. When the air is humid, the water molecules in the air can reduce the electrical insulation properties of the air, making it more susceptible to corona discharge. 2. Conductor size. The corona effect depends upon the shape and conditions of the conductors. The rough and irregular surface will give rise to more corona because unevenness of the surface decreases the value of breakdown voltage. So a stranded conductor has a regular surface and hence gives rise to more corona than a solid conductor. 3. Spacing between conductors. If the spacing between the conductors is made very large as compared to their diameters, there may not be any corona effect. It is because larger distance between conductors reduces the electrostatic stresses at the conductor surface, then avoiding corona formation. 4. Voltage level. The line voltage greatly affects corona. If it is low, there is no change in the condition of air surrounding the conductors, and hence no corona is formed. However, if the line voltage has such a value that electrostatic stresses developed at the conductor surface make the air around the conductor conducting, then corona is formed. 5. Pollution. Air pollution can increase the likelihood of corona discharge by introducing particulate matter and other pollutants into the air. These pollutants can reduce the air's dielectric strength, making it more susceptible to corona discharge. 6. Age of transmission line. The age of transmission lines can affect the corona discharge effect by altering the electrical insulation properties of the transmission line. Older transmission lines can be more susceptible to corona discharge. Now that we've covered factors affecting corona discharge, let's explore the disadvantages of corona discharge in transmission lines. Corona discharge in transmission lines can have significant technical disadvantages, impacting the efficiency, reliability, and safety of power transmission systems. Here is a detailed examination of disadvantages of corona effect. 1. Energy losses. Corona discharge can cause energy losses due to the ionization of air around conductors. When the electric field around a conductor is strong enough, it can ionize the surrounding air, creating a conductive pathway for electrical current to flow. This can result in energy losses, reducing the overall efficiency of the transmission line. 2. Radio interference. Corona discharge can generate radio interference, affecting communication systems. The high-frequency electromagnetic radiation emitted by corona discharge can interfere with radio communication systems, causing disruptions to critical communication services. 3. Audible noise. Corona discharge can produce audible noise, which can be a nuisance. The hissing or crackling sounds generated by corona discharge can be heard near transmission lines, causing disturbance to nearby residents. 4. Insulation deterioration. Corona discharge can deteriorate insulation materials, reducing their lifespan. The high-energy particles generated by corona discharge can damage insulation materials, leading to a reduction in their lifespan and potentially causing equipment failure. 5. Corrosion. Corona discharge can cause corrosion on metal surfaces, leading to equipment failure. The chemical reactions triggered by corona discharge can cause corrosion on metal surfaces, weakening the structural integrity of transmission line equipment. 6. Electromagnetic interference. Corona discharge can generate electromagnetic interference, affecting nearby electronic devices. The high-frequency electromagnetic radiation emitted by corona discharge can interfere with electronic devices, causing malfunctions or data corruption. 7. Power quality issues. Corona discharge can cause power quality issues, such as voltage fluctuations and harmonic distortion. The ionization of air around conductors can cause voltage fluctuations and harmonic distortion, affecting the quality of power transmitted. 8. Reduced equipment lifespan. Corona discharge can reduce the lifespan of transmission line equipment, such as insulators and transformers. The repeated exposure to corona discharge can weaken the insulation and reduce the lifespan of equipment. 9. Increased maintenance costs. Corona discharge can increase maintenance costs due to the need for frequent inspections and repairs. The potential for equipment failure and power outages requires frequent inspections and repairs, increasing maintenance costs. 10. Environmental concerns. Corona discharge can raise environmental concerns, such as ozone generation and electromagnetic pollution. The high-energy particles generated by corona discharge can create ozone and other pollutants, contributing to environmental degradation. Having discussed the disadvantages of corona discharge, we will look at strategies for mitigating corona discharge. Corona discharge is a significant concern in electrical systems, leading to energy losses, interference, and equipment damage. Effective mitigation strategies are crucial to minimize its impact. Here are the key methods to reduce corona discharge. 1. Increasing conductor size. Larger conductors have a lower surface electric field strength, reducing the likelihood of corona discharge. This approach is particularly effective in high-voltage transmission lines. 2. Using bundled conductors. Bundling multiple conductors together is another effective strategy. This technique reduces the electric field strength by distributing it across multiple conductors, thereby minimizing corona discharge. Bundled conductors are commonly used in high-voltage transmission lines to reduce energy losses. 3. Improving conductor surface condition. The surface condition of conductors plays a critical role in corona discharge. Smooth, clean, and dry surfaces reduce the likelihood of corona discharge. Regular cleaning and maintenance of conductors can help achieve this. Additionally, applying specialized coatings or treatments can improve the surface condition and reduce corona discharge. 4. Using corona rings or grading rings. Corona rings or grading rings are devices designed to distribute the electric field more evenly around conductors. By doing so, they reduce the electric field strength and minimize corona discharge. These devices are particularly useful in high-voltage applications, such as transmission lines and substations. 5. Increasing spacing between conductors. Greater spacing between conductors reduces the electric field strength, making it less likely for corona discharge to occur. This approach is effective in designing electrical systems, such as transmission lines and substations, where conductors can be spaced farther apart to minimize corona discharge. 6. Using specialized coatings or materials. Some specialized coatings or materials can reduce corona discharge by minimizing the electric field strength. These materials are designed to absorb or dissipate electrical charges, reducing the likelihood of corona discharge. Examples include silicone-based coatings and specialized insulators. 7. Regular maintenance. Regular inspections and maintenance are crucial in identifying and addressing issues that may contribute to corona discharge. This includes cleaning conductors, checking for damage or wear, and replacing faulty equipment. By maintaining electrical systems regularly, the likelihood of corona discharge can be minimized. In conclusion, the corona discharge effect on transmission lines is a complex phenomenon influenced by a multitude of factors. Understanding these factors is crucial for utilities and transmission line operators to identify and mitigate corona discharge issues, ensuring reliable and efficient power transmission. By considering these factors, utilities and transmission line operators can take steps to reduce the likelihood of corona discharge and ensure the reliable operation of their transmission lines. If you find this video helpful, please like, share, and subscribe to the channel. Bye and have a nice day.